Okay. Hi there, partners. Thank you so much for joining us for today's webinar. I see many people online, and I guess that a few more are going to join us soon. Our team, we have important people, important ribbon speakers here. We have David Stokes, Head of IP Solutions and Portfolio Marketing. We have Jonathan Homa, Senior Director of Solutions Marketing. And we have Elias Siegler. And again, it's not easy. Elia, you're gonna correct me later, who is our senior solutions architect. We're gonna have a very interesting discussion today. Thank you for those who sent us a few questions via email. I remind you that you can also um, contact us by the Q&A. You can write in the Q&A any question. If it's relevant for all of us, we're going to try and answer it during the session or at the Q&A at the end. If it's more, directed just to your company, then we will for sure contact you after the webinar and discuss it with you. So any question, general, private, please put it in the Q&A, and we will get to it as soon as possible. So without further ado, David, go ahead.
Thank you, Yoav, and thank you everybody for joining. Wow, what a big subject area rail evolution is, and we're just going to skim the top layer of what we at Ribbon can do within our packet transport and optical networking to help move your end customers forwards in their rail journey. And that deliberate Freudian slip there. So what we're seeing, and the rail industry is right in the middle of at the moment, is a number of conflicting needs, driving quite a lot of focus on what they're doing. So there's a huge need to increase freight and passenger numbers, but at the same time, there's loads of pressure on everybody, and rail is no exception in reducing carbon footprint. So on one hand, they've got to increase everything. On the other hand, they've got to reduce their carbon footprint. And then I think we all know, and we're all end customers, we want better customer experience everywhere we go. We expect to be online the whole time. We expect to be able to see, immediately see what's happening on our transport networks, rail being no exception, and be able to understand when we're going to arrive, when we can buy tickets, etc., etc., etc. So a lot of pressures, which is then driving increased regulation and increased safety requirements for rail. So what this all means that rail is in the process of modernizing, massive modernization exercises going forwards. With electrification and digitization of their network, to increase their frequency of trains, better use of the track and rolling stock, ERMTS, CBTC, and also to improve the reliability of maintenance and security with RAMS type systems. We see a little bit further out in the next 2-3 years, it is time to roll off the GSMR type network and move on to FRMCS, just a better wireless technology to meet those needs I outlined. And then to increase the customer experience, the whole area of smart mobility, all the way from ticketing through for infotainment type systems, either on board, in station, or even approaching the station. And then, of course, the whole things around station management, station monitoring, station safety, with loads and loads of CCTV monitoring what's going on, so we know it is a safe environment. And then finally, many of our rail customers have realized that they've got a really unique infrastructure that's laid out when they started to deploy this type of network. And that's perfect to make extra revenue streams through evolving to you telco, offering business or residential type services to end customers as a service provider. So we're going to touch on all of these today. Jonathan's going to explain the optical side of our story, and Elia is going to explain the packet transport side of our story. But I think it's worth saying that whilst I've got two different people explaining the story, it is actually a converged story for Ribbon. We can provide packet transport IP routing, and we're best in class for rail in doing this. Really, really one of the leading vendors, especially in Europe. And similarly for the optical story with our Apollo portfolio. But with our automation systems, we're able to converge the two together to provide a converged IP and optical story across both the packet transport and IP optical networks. So, Jonathan, I mean, talking about that automation, maybe you want to start talking about one of the special things we do about controlling the network.
Thank you very much, David. I'll pick it up from here for the next number of slides. This was a slide we could have put at the end sort of as a wrap up for the presentation, but we think it's important enough that we put it up at the front so it doesn't get lost. In terms of the solutions that we working with you produce for our customers, most of these solutions fall into the domain of an IP plus an optical solution, bits and pieces of each, sometimes oriented towards one or the other. But ultimately, it comes down to running a network. And we also provide tools to our customers to run their networks. Originally, it was through the LightSoft network management system, and now we're in the process of evolving that towards our Muse SDN orchestrator. But whatever it is, we provide our customers, or we provide you, if you're system integrators, on behalf of our customers to manage the network. But in many cases, customers don't want to manage the network themselves, or they're looking for backup in terms of managing their network, say during off hours, weekends, so that they have 24/7, 365 coverage. And one of the services that we can offer, and we can also set you up to offer it yourself if you want, is a network operations center as a service. What you see in this picture is such a network operations center that we're actually providing to DB Systel, who is running the network that we provided to Deutsche Bahn. So this is just something to sort of raise your awareness that here's another kind of value added service that you can provide on top of the network solutions that we're selling. And we wanted to make sure that this type of thing was not lost. Next. David, since you're flipping, thank you. So optical evolution in rail. Next slide. In terms of the IP optical infrastructure, of course, the role of optical is to provide the heavy lifting in terms of lowest cost per bit. And typically, this is found in the majority of rail solutions, sometimes by itself, sometimes as an underlay for transport to the IP solutions that David and Elia will be talking about in much more detail. So it's worthwhile giving an overview right now of how we provide this particular foundation. You're probably familiar with our product lines since you're partners on this call, but this is worth doing a quick recap. We have three main product lines today, starting off in the middle. This is the 9600 series, probably what you're mostly familiar with. It's sort of a general purpose workhorse for optical transport. It provides transponders and muxponders, which map client interfaces onto wavelengths. And then it provides an optical line system, which enables you to manipulate these wavelengths through the network, maps them onto DWDM links, multi-wavelengths on a particular link. And it enables you to add and drop particular wavelengths to particular links. And this comes in three sizes of platforms, 2RU 9603 all the way up to a 15RU 9624. All cards are equally, that is made for one platform, can be used across any platform, that you have a complete ability to create a right size solutions for your customers. Similar capabilities to the 9600 series is a new series we're introducing this year. And I thought just while bringing it to your attention, this is the 9400 series. This is specifically meant for very high density applications. It's in a different form factor. It uses a box which is 600 millimeters deep, and it uses front to back cooling, specifically optimized for use in data centers. This is the kind of boxes that sort of came onto the market a few years ago, driven by the needs of web scale providers. And now typically a lot of the very large service providers are asking for this kind of solution. I would say typically for rail solutions, this kind of box is not needed today, which is why I don't have that sort of blue double-sided arrow on top, rail solutions extending to that, but you never know. So if you have a customer that is looking for something, say, which is oriented towards a data center, or is looking for something which is very high density, just know in your sort of the back of your mind that we have a solution for that as well. And then the other kind of solution that we have is the 9900 series, which is an OTN, a set of OTN switching platforms. Again, very scalable, going from access platforms, which is the 9901, all the way through metro regional 9904X, up to 5.6 and 16 terabit per second backplanes, which are meant more for core network applications. And here, typically, you'd find major use for the access and the metro platforms. And we'll talk about some use cases for these in the coming slides. But this is an overview of the building blocks that are available for you to provide optical transport solutions. Next slide. So here is typically how you would use the major types of cards in these platforms to provide optical solutions for rail. So for rail, you'll have all different types of OT and IT, different types of traffic sources, some used for operational purposes, well, all used for operational purposes. Eventually, in some cases as well, you could extend this as a services, say as a utelco kind of thing, but we're not going to address that today. But there's many different types of services, operational, like your SCADA services, your CCTV services, and all the types of things that the consumer sees, and also the types of things that you use for internal operations purposes. And these get mapped onto different types of clients. They could be 1 gigabit Ethernet clients, or they could be fiber channel for data center applications, or they could be sort of legacy TDM type of traffic. And what you see on the left is the various ways that you can use optical to aggregate this traffic. Probably you'll find as you get deeper into the presentation, you'll do most of this aggregation using the packet layer, layer 2 or layer 3. But in many cases, customers are still aggregating traffic at the optical layer. It has certain advantages and disadvantages based on the kind of architecture and philosophy that your customer has. But you're seeing that there's two ways to aggregate the traffic. You can do this using transponders or muxponders. And here we show two different kinds of line cards for the 9600 series, the TR10-12 and the AUC10C. And they aggregate different types of 1G to 10G clients of the types that I've mentioned, gigabit Ethernet, fiber channel, or STM. You also have a way of doing this using an OTN access switch. This is the 901X access switch. And what you're doing here, again, you're aggregating these same low-speed clients onto a single onto pairs of 100G wavelengths. Once you've done this aggregation, you need to bring this traffic deeper into your network. And again, you have two options. You can use the 9600 series, and here we show a number of cards, which are able to aggregate the sort of the 10G traffic coming off the access layer onto 200G or 400G wavelengths. Or in the case of OTN switching, you can map this traffic coming off the 100G interfaces onto a metro or core OTN switch, and then go deeper into the network with 400G interfaces. Once you have all this traffic mapped, though, onto the DWDM links, you'll be using a common set of ROADM boxes provided by the 9600 series to switch these wavelengths through the network. And if you have a need to do long distance transport of these wavelengths at higher speeds from 200G, 400G, and today even at 800G, then you have a number of line cards that you'd be using in the 9600 series to do that, including the TM800-2, which is just being introduced now for 800G wavelengths. So the nice thing about this is a set of building blocks. I've shown you the key building blocks over here, and you can put these together as I'll show you in the bottom right-hand corner. Solutions can be mixed to customize and create a tailored solution for your customers. Let's look at a few cases in terms of how actual customers are using this. Next slide, please. This is a solution we've implemented for a Northern European rail customer. This has not been announced, so I can't name the customer. In this particular case, the customer only wanted to stay with 10G wavelengths, but they did have lots of different types of client traffic, including 10G clients and 1G clients. So they used a number of the two different muxponders that I talked about before, well, the 10G transponder and the ADM, the add and drop multiplexer. They're bringing this traffic as 10G wavelengths into their network, and then they're routing it through their network using fairly simple ROADMs that are only sized towards 4 degrees. Not a very complicated network, but again, handling all the aggregation at the optical layer. Next slide. This is something we announced a few years ago. This is a network that we put in place with our partners for SNCF. SNCF, of course, is a large rail operator in France. And what they were looking to do was upgrade their operational and their transport infrastructure in and around the Paris area. And again, based on their architectural philosophy, what they decided to do was rather than use the rather than use DWDM transponders and muxponders, they really took a liking towards using the 9901X access OTN switch. So again, what they're doing is they're aggregating all their traffic with the 9901X, and then they're bringing this into the network and actually routing it around the network using the mid-size 9904X Metro switch over here with speeds up to 400G. There's sort of pros and cons of using DWDM versus OTN. The OTN will tend to be a bit more expensive. However, it gives you much greater granular control over the services in terms of bringing them through their network. So a lot of this really depends on the architectural philosophy and how you want to be able to bring traffic into the network, segregate it, and it also provides you additional flexibility using OTN switching in terms of service availability using architectures such as the ASON or Automated Switched Optical Network. Next slide. This is my last slide in this particular series, and here we're talking about a much larger solution. Again, this is a solution we provided in conjunction with DB Systel for Deutschbahn. It's a very large network, of course, covering the entire country. They're actually using two different types of aggregation schemes, both using for the 1 and 10G add and drop multiplexer on the DWDM side, and then also using in certain applications the 9901 access switch. Again, bringing these wavelengths at 10G and at 100G into the network, the aggregation takes place at a more detailed level using the TM200EN, which provides optional encryption. This is going through a larger ROADM network with up to 20-degree nodes, and then they're doing their sort of backbone transport through the network at 100G and 200G wavelengths using the TR200-2. So what you see here is a much more extensive solution going all the way from the aggregation layer using both muxponders as well as OTN switches, going through one level of aggregation, going through ROADMs, and then going into a long haul backbone. So very powerful solution. And by the way, as I mentioned before, we also work with them to provide a network operations center so we can supplement the coverage that they're providing during off hours and weekends in terms of they have 24/7, 365 coverage over the operation of their network. So I hope this gives you a glimpse of the kinds of ways that we use the different optical building blocks to provide solutions for our optical solutions for our customers. David, Leah?
Okay. Are there any? I would pause for
Maybe we
1
should
second to see if
pause
there are
here.
any. Yeah, to see if there are any questions at all for Jonathan specifically on the optical side.
Thank you, David. There was one asking Jonathan, how do you compare using an OTN muxponder versus an OTN access switch?
Okay. I think I'd mentioned that already, maybe just to recap a couple of points. They both do a similar function. What you're doing is you're aggregating lower speed interfaces, 1G, 10G interfaces into your network. Using a muxponder is a more economical solution, but what you're forced to do is map all the services at one location onto a specific wavelength, and then they're stuck on that particular wavelength. And you've got to engineer that all the way through the network, unless you convert it back to the electrical domain. With an access OT and switch, you have more flexibility. So for instance, say you're connecting a number of stations that are in close proximity to each other, you can service all those stations, say, with a single 100G wavelength. And this could be a black and white wavelength. It doesn't even have to be a colored wavelength. And then what you can do is put in 9901X access OTN switch at each one of those stations, and then aggregate the lower speed services all onto that single wavelength, which at a later stage you bring into the network, say into another OTN switch, and then you can combine it with other traffic. So a lot of it depends on the architecture, the kind of flexibility that you're looking for. There's pros and cons to each. And like I've shown you in one customer, they just went with the muxponders, another one like SNCF, they went with the access switch. In the case of Deutsche Bahn, they actually went with both depending on the situations. Work with your sales engineers, understand the requirements of the customers, both from an operational point of view in terms of their cost targets, in terms of their operations targets. And again, we'll come up with a solution which makes the both sense. So it's not that one's better than the other. They provide slightly different approaches to a similar problem with different pros and cons in terms of cost and flexibility.
Thank you, Jonathan. And I see another one in the Q&A. Again, if you can answer it now, great. If not, we'll get back to the person later. He asks, I heard Ribbon announce 1.2T wavelengths. Do you see this as relevant to rail?
Not today. 1.2T wavelengths is primarily relevant to extremely high density, high speed traffic, typically in terms of data centers connecting with each other within a metropolitan environment where they need to do continuous synchronous replication of data, and you have these, huge rivers of traffic flowing between them. Eventually, rail may catch up to these kinds of traffic needs as the kinds of services and, say, video streams grow at the different stations. But by that time, I would say that 1.2T would be sort of what you might see as 400G today. And then in terms of what the data sensors would be looking for, it might even be, double that particular speed. I think it's important for railway people in the railways to understand that at least working with Ribbon will always be, at least on the optical side, at least one step ahead of what they actually need in terms of being able to handle their traffic carrying capacity needs.
Beautiful. Thank you, Jonathan, and thank you for the questions. I think that we can continue. Go ahead.
Okay. Yes. Thank you, and thank you, Jonathan. And one of the things you mentioned there about working with the Ribbon sales engineers and tailoring the solution specifically to meet the customer's needs, whilst you mentioned it for optical, is equally relevant for both IP and optical. As Jonathan said at the start, you can do some of this aggregation in optical, you can do some of it in IP. One of the key values, as you know, working with Ribbon is the ability for us to work with you to tailor solutions to meet the customer needs today and going forwards. And the mix between packet and optical is absolutely part of that. So whilst we've split it, IP and optical, this presentation is about looking at all the assets and tailoring the solution to meet your end customer's needs. So going on to the packet area, why is packet so important? Well, with all these different services I mentioned and drivers at the start, there's a huge range of different bandwidth needs, capabilities, performance needs required, and packet transport is uniquely placed to optimize that in the most efficient way, whether that be for the IT, OT systems that are required in a modernized railway application set, the safety critical stuff, maintenance and diagnostics, business applications, or it be for the advanced passenger services, as I mentioned, which everybody expects today. Packet is really, really well placed to deliver those sort of solutions. And what one would expect from a packet solution is to be able to support all those different services delivered over whatever the access network might be, whether that be fiber, copper, Wi-Fi, cellular, 4G, 5G, GSM. It needs to be able to support all of those. For those services that are business and mission critical, that packet transport has to be deterministic, so you know precisely the latency, etc. More and more, we're seeing a need that the configuration of that network and how that deterministic packet work needs to be software defined. And then we talk about the evolution to FRMCS, integration with the optical layer with IP over WDM, and of course the solution that has to be high availability. 5 nines is a critical infrastructure after all, so high availability and very, very resilient to failure. And with all this complexity, you need an automation capability over arching everything. So over the next few slides, I'm going to hand over to Elia, where she's going to do a deep dive in a number of the really key elements of this list. So Elia, over to you.
So one thing we need to anticipate in the very, very near future is the digitalization of the railway system. In Europe, this would be the future railway mobile communication system, or the FRMCS, which is the successor of the long-standing GSMR. Here on the slide, I wrote here the German frequencies, but in Europe, we will have the sort of in the same range of these frequency bands. The first implementation, or testing for that matter, are expected with allocation of the 1900 to 1910 megahertz, and this will be allocated in 2025 in most networks or most railways in Europe. And this will come with a new requirement in the transport network, which is expected to be at least IP/MPLS, and if not, segment routing. So there is now a lot of plans in railways to move from legacy networking into IP/MPLS and or segment routing. Now, there's another aspect why I put these two bands here, the GSMR and FRMCS, because at some point when FRMCS comes, GSMR and FRMCS will coexist for some time. So good thing lasts in this case. Therefore, the railways may need to implement some kind of network slicing at the transport level, both in optical and IP, to segregate these two radio technology, which I will explain later what approach has driven on this. Next slide, David. Next slide. So, we talked about FRMCS, but it will not be the only radio network in the railway. It will share the same geographical area with, for example, private 5G frequency. Here in Germany, it's from 3.7 to 3.8 gigahertz for private 5G, as well as frequency used by mobile network operators, because along the railways, the passengers need to access as well the mobile network, the commercial mobile network. So all these frequencies will coexist in the same geographical area. In the case of railway UTelco, you might need to have a higher capacity IP transport network. And we are seeing at least 10 gig uplinks to 100 gig uplinks in these cases. But on the other side, if only FRMCS and GSMR are needed to be carried in the IP transport, you've got, we're seeing gig E to maximum 10 gig uplink. This would be enough, because for FRMCS, if you look at the frequency band, this would be classified as macro cell, meaning that the uplink would be more or less on the average 200 megabits per second. So you would need to have a high, a cost-efficient IP router or cell site router on this to bring the cost down, and to as well as to carry the needed traffic. Next slide. So I was sort of illustrating varied scenarios. So for these scenarios, Ribbon has complete X-hole solution on this slide. We've got the right form factor, so you can choose between modular or redundant system. We also have fixed system. We have different performance capacity for example, for cell sites, we have 3 options you can have. For hub sites, we also have 3 options you can have, as well as the metro and aggregation side. We also have 3 options. And if you look at the cell side, the NPT 1100 enables you to have 100 gig uplinks. So I was talking about railway utelco use case where you need 100 gig because you're carrying also the mobile backhaul, the X-hole of mobile network operators on the same IP network. So that would also be possible with the 1100. And the 1100 also supports IP over WDM, which is also one of the new technologies that we support today. And then you got the 1022, which is very efficient for 10 gig uplinks. And this 1022 and 1100, these are our best sellers. These are deployed in mobile networks. Now, today I was talking about macro cell site and carrying FRMCS and GSMR. For cost efficiency, we have a new member in the Neptune family, which I'm going to introduce today. I think this is the debut for this Neptune. I'm going to show it to you. This is the 1012D. Hopefully it's not upside down. No, it's upside down. Good. So it's exactly half of the 1022, but the capacity is half of the 1022, and it is well designed for macro cell site, which has would need 10 gig uplinks as well, or gig E uplinks in a very cost efficient way. And this
I was going to say,
router,
Elliot, one other thing about that is it can go through 90 degrees to be DIN rail mountable.
Yeah, exactly. So at the back, you can plug it in on DIN rail. So it's really nice. I'd like to have a few of these at home and build my own new mini network. It's really cool. I like it. It supports all the IP features you have with the 1022 and 1100. So it does MPLS-TP, SR, SR-MPLS. It does IP-MPLS, EVPN, and all those good stuff, as well as 5G synchronization, because it is important to have 5G synchronization for FRMCS. So you've got here the GNSS receiver here, and it's Class T clocking. So there you go. I think you can already order this one, as far as I know. Yes, so yeah, that was the debut of the 1012D today. I think it's the first time we've shown it publicly on its flash, of course. The data sheet can be downloaded from the website. And lastly, on this picture, you see the MUSE SDN orchestration, which enables automation. And this can be integrated into the railway's own automation systems with our open interfaces. Yes, this is very critical for railways digitalization. Next slide. So I've spoken about IP-MPLS and SR-MPLS, but some railway network will not be ready to jump into an all IP network, and that's okay. We provide MPLS-TP, which is a proven technology for critical services. And since networks in critical infrastructure stay at least 15 years, if not even 20 years, we made sure that railways can transition if they choose to do MPLS today. So we made sure that they can transition from MPLS-TP to IP-MPLS or MPLS-TP to SR easily in just one platform, and that is our Neptune or they can even have both MPLS-TP with SR in Neptune or MPLS-TP and IP/MPLS, whichever they think that is best for the network. So we have that options for railways. We also provide traffic segmentation at all levels. So it may be on our optical layer, it could be over FlexE, or it could be over IP. And these are all automated using our Muse orchestration. Next slide, David. So I would just like to highlight that in most cases, MPLS-TP will be the starting point. Especially if there are still legacy services in the network. So you cannot just get rid of your SAS, for example. So, and you cannot just switch it from GSM-R to FRMCS. This will coexist for some time, for some years. Knowing that FRMCS is still 2 to 3 years away to be widely deployed. So we think that MPLS-TP needed to be brought to the next level, as we say, by integrating it with our Muse SDN controller. So now we have MPLS-TP SDN controlled, while still maintaining the 3 capabilities here on this slide, like transport, like OAM, performance monitoring, SLA verification. Importantly, the bidirectional paths that you don't really have automatically with IP/MPLS and SR, and the sub 50 milliseconds protection switching that we all got used to in critical infrastructure. So you've got it to MPLS with MPLS-TP, and as well as assured end-to-end latency and jitter, which is important for some critical services. Next slide, please. So one other aspect in new generation networks today is IP over WDM. Depending on the network, we provide options for railways to optimize their network. There will be cases where it makes sense to have directly connected routers, so NPT to NPT with coherent pluggables. So we support QSFP, DD on our Neptune. If the fiber is available for it, then go ahead. But in some cases, it would make sense to have it over OLS. So this picture, you can see that we also support NPT or IP over WDM over OLS. It doesn't need to be Apollo. It could also run on third-party optical systems. But of course, Apollo supports that. Or we could also use gray optics for IP over OT. So we also support that one. So we have all these choices depending on the economics that the railway would have in their network. So not all networks are the same. Some may have an advantage to directly connect NPTs together, and some may have an advantage to connect through an OLS or an OTN network. So next slide, David. So I have mentioned traffic segregation or network segregation. So Ribbon IP Optical provides what we call in 5G mobile networks as network slicing. Here we provide hard slices. This would be either fiber or over wavelength or their FlexE. Or we could also provide soft slices. It could be over MPLS-TP, SR, over VPNs, or we can have a combination of both. Actual network slices on the network are neatly presented over Muse SDN. So the slices exist in the network, and the logical constructs or the logical context will be illustrated neatly on the Muse SDN controller using this multi-tenancy feature. So you know what the slice is for, where it is in the network, and where it is connected. And you see it over our Muse SDN controller. Next slide. I think the next slide is for you, David.
Yeah, yes, it is, Elia. So thank you very much for that, Elia. Do we have any questions for Elia
Yeah,
on
David.
the
Two for Elia. First one, will segment routing cover all requirements for future railways?
Um, as we all know, segment routing came from the service provider network, and it did took some time for it to become mature and complete the whole ecosystem, meaning, you know, the high availability part, the protection, the OAM, the telemetry, and all that makes it really robust. Uh, it is widely deployed in service provider networks, but as in any other technology, the critical infrastructure is always a bit late because they need something that is proven, mature, and, you know, that everybody knows that it would work on critical infrastructure. And this is the same way as the 5G. 5G started in service provider, and the standardization and specification for critical mission critical services came only in the later 3GP releases. So it will come in a bit later. So I would say segment routing will have uh, all what is needed in the railway network, but I don't think that the critical infrastructure will jump onto it, you know, um, right away. It would take some time for segment routing to become widely uh, deployed in not only in railway but also in critical infrastructure. Now this is why we are, you know, trying to bridge the gap from that state of segment routing from today. So we have the MPLS-TP, we have the IP MPLS, so we can start with that one, and then in 2-3 years time or 4 years time, when FRMCS is really there, segment routing might have already what it takes to be in the critical infrastructure environment. So I see there's potential there. It's driven mainly by automation, the capability of the segment routing to have automation and programmability. So that's why we really need segment routing, but it would, I think, take some time to be really ripe for critical infrastructure networks.
Okay, good. Okay, good. And another one coming from one of our partners in the Middle East. I've heard some talk about circuit style segment routing. What are your thoughts?
This is one of those things that it has potential. It looks good. It is on an IETF draft. People are talking about it. If I'm a service provider, I am doing, yeah, it's okay. It's circuit style. It's supposed to be for critical infrastructure. I am happy with that because we see that segment routing is now creeping into this critical infrastructure, but it still is not the case that it would compete in terms of maturity. It would compete with MPLS-TP in a way that you can implement it today. It's like, if you're going to implement it, you will be the first one to implement it. So would you take the risk or you want to have somebody else or a service provider to experiment on it, learn from it, and, you know, fix all the bugs on it, whatever it has. But we know that it is in the IETFs being talked about. It's got good potential. We're monitoring it, but if you're going to do something today, it's MPLS-TP. And by the way, the very base of circuit style is segment routing. So we have it already. It's just a matter of a few tweaks, and then we can deploy it. But it's just like, who's going to deploy it today?
Thank you, Elia. I mean, one thing I would add to that is basically within, you know, the service provider routing vendors like us, we've been scrabbling to get back to where we were with SDH in terms of circuit style. MPLS-TP does it really, really well. And basically, circuit style SR seems to take us back to where we are with MPLS TP today. Obviously, with the advantages, you have one unique segment routing network that works across everything. But I think that's where circuit style segment routing probably fits. And MPLS TP gives you everything you need until
Yeah,
that
and
becomes
you can do it
technology.
today, and it doesn't mean that you don't have circuit style if it really takes off in 2-3 years. You can use it. We have segment routing, which is the transport base for circuit style. So yeah, I'd keep monitoring it, and I'd like to see some testing, and I'd like to see it deployed at least for some test networks, and then yeah, that's
good to hear. Good to hear. And one other thing to mention there is, because of our multi-stack approach that Elliot mentioned before, you don't have to do a forklift when we do the upgrade. We've in a number of customers, including a super huge network in India, migrated from MPLS TP to IP MPLS within an in-service network of many thousands of nodes. So once you've deployed the Neptune running MPLS TP, if that's what you're running, we can upgrade to the other signaling protocols as and when you want to introduce them. There's no forklift required. It's just a software upgrade. So I think that really helps in that evolution approach. And talking about evolution approach, once you've got this network in place, you are in a really unique position. If your local regulation or your customer's local regulation allows it, to actually make new revenues by starting to offer services either to other service providers or to end customers themselves. So why do I say that? Well, once you've got your network in place, by the very nature of the rail network, you have all the wayleaves you need to gain access to some very, very sought after locations that service providers just can't gain access to very, very easily. Now that might be for offering mobile backhaul because they can't get connectivity to their radio network. It might be into remote locations, which is just too expensive for the normal service providers to gain access to. You have that wayleaves because, sorry, your customers do, because their rail network extends to those places. And now with that network and that geographical footprint you have, clearly, as we've explained already, you'll have an IP optical network in place for your own needs, your own IT and OT needs. So there is a network there. And as Jonathan mentioned, that the optical bit of that network running DWDM and 800 gig wavelengths. Now, if you're thinking whatever it is, 48 or 96 wavelengths in a single fiber. Now you're talking terabits of data there, plus it's a fiber bundle almost certainly. So you've got quite a lot of capacity in that network, which you could use for selling services onwards. In addition, the capabilities that Elia mentioned with the whole segmentation or network slicing allows you to give a separate hard slice to different tenants on the network, so different customers, and completely segregate it from others. So again, it's a unique capability that allows you to run multiple different services to multiple different types of customers. And then within the soft slicing that Elia mentioned, you can start offering differential service performance, given a different soft slice to each individual customer type. And then with this new SDN orchestrator that Elia mentioned again, you don't have to be a Cisco certified engineer to be able to configure the network to set up the services. That automation system sorts all that out for you. So actually, you can start offering services, even some quite complex services. The automation system takes away some of that complexity and puts you in a very good position to do that. And also, so then looking at the sort of services, you can take it byte by byte. And when you're comfortable and your business is used to running as a service provider, you can take the next level. So you might start off by offering wholesale services to other service providers, bandwidth backhaul. I mean, in the lowest complexity, dark fiber, but I would say that's a big waste of revenue opportunity. You could very easily offer lit fiber, and then you move through to mobile backhaul to mobile providers, business services, residential broadband backhaul, where you either do the residential access network or you partner with someone doing a residential broadband network. And we do have many examples of each of these, by the way. Particularly in North America, we're doing the residential broadband quite a lot, backhaul quite a lot, the mobile backhaul in Europe, and then some even offer smart city infrastructure. So then really, really great opportunity with your network that you have in place for this modernization to generate extra revenue. Just one question: are people still seeing the slides? Because I've gone from my network.
Yeah, we can see David.
Okay, brilliant, thank you. So anyway, it's the last slide anyway. So it's basically gonna summarize what we've talked about today. You've got with Ribbon, you now have an IP optical network that you can offer your customers to meet their modernization needs that I explained at the beginning, though, with the multi-stack MPLS, providing that deterministic IP transport, the automation. One thing Jonathan didn't mention, I don't think, was the fiber health monitoring on optical, being able to locate very, very specific locations within 3 meters of where a fault might occur, massively reducing the time to repair and fix outages. But it's also very, very proven solution for rail. We have a large number of deployments in a large number of countries now, from Europe, across the Americas, India, and Asia. So it's a very well spread, proven solution. And every single customer is different and has different needs based on these building blocks that Jonathan and Elia mentioned. And we and our sales engineers are very comfortable working with you as partners to build the right solution that's scalable to meet the right needs for those customers that you are dealing with. And of course, that solution has the mission critical grade service delivery and availability that you need in those networks. And it goes without saying that we have all of the various requirements and standards compliance needed in rail, particularly around the security area. Now, whether that's a NERC SIP enabled or SDL, ISO 2700, etc. So it has the security, it has the standards compliance, and we can tailor solutions to meet those specific needs. So I think that's brings us to about a couple of minutes left for questions. So any further questions, Yoav?
Yeah, two more. I guess those are for you. Does the solution work for GSMR, FRMCS, Macro, and ORAN?
I can take that, and Elia can chip in it if she would like. Yeah, and basically the way we build our access router portfolio is it can support any service delivered over any access network. So we don't have an axe to grind where we have to support a single type of cellular network or a single type of Wi-Fi network. We'll take any Ethernet stream in that comes from those and a number of analog streams from other type of devices and transport those across the network with the service performance meeting what's required for each of those services. And the SDN orchestrator really helps achieve meeting that service performance need. Anything to add, Elia?
Well, ORAN was mentioned, so ORAN is quite standard, and the railway FRMCS is also based on 3GPP standard. So not that it means ORAN is 3GPP, but it's actually supplement or complement, whatever the right word it is. So it's part of the mobile network, and yeah, so it's it's part of 5G. I would say O-RAN was in the same wave as 5G, and we support because our platforms are present in both service provider network as well as critical infrastructure. So we have these two in mind, and absolutely O-RAN can be deployed in a railway network, and so are our platforms.
I mean, one thing I will add to that is that for anyone who has any doubt about the whether O-RAN is real or is something in the future now, not just a far-flung future, is on the commercial service provider market. You may have seen that AT&T announced just last week a £14 billion deal for O-RAN with one of the major radio vendors, Ericsson. So yeah, O-RAN is very real. Any other questions?
Yes, David. Last one. I think it comes from the UK. At some point, you said that there is a range of different sizes. Are there other factors other than capacity that determine which router should be chosen?
Okay, yeah, this is part of that being able to offer the tailored solution to meet operational needs. So yeah, the various form factors that Elia mentioned, you might decide to choose a router based on the switching capacity. You might decide to choose it based on the interfaces it supports. You might decide to choose it because it's modular and fully redundant, or you might decide that you don't want that redundancy in the network element. You want to do some redundancy in the architecture itself using dual homing. So with that full range of form factors we have, we can work with you to meet those precise needs of the customers. So even within those network elements that Elia said for the 5G, there are variants on those families. So the 1022 has a number of different variants specifically for particular needs. And then we have other network elements, form factors that fit in around those ones that are highlighted. So the short answer is here, yes. Basically, we have one common software that runs across all the form factors, and you choose the form factors based on customer needs, and we help you do that to service the end customer's actual needs today and as they evolve. And the nice thing about that, having that common software across all of our portfolio, is that as we introduce new form factors, you don't need to relearn the capabilities of our network elements. The just new form factor comes in. It has the software that you're used to, plus the evolution of that software, of course. But it has that, and then you can just put that new form factor in as required. So I think that probably answers the question. And that probably takes us to the end of the hour as well. We would love to answer any more of your questions, so please contact us going forwards, and we'll endeavour to answer any questions you have. And we really enjoy working with you and moving the rail industry forward. So thank you very much.
Yep, thank you to all three of you. I think that we covered 2023 webinars. We had private optical networks, we had one for utilities, we had one for rail. And by the way, for you partners, I've added the link to all our webinars. It's on rbbn.com, so you can find it in the Q&A. And we'll probably meet again during 2024. So thank you and see you next year. Bye-bye.
See you. Bye-bye.
Bye-bye.
Bye all.